Two and a Half Admins, episode 174. I'm Joe.
I'm Jim.
And I'm Alan.
And here we are again. Let's do some news then. And the first is an SSH vulnerability that's being called Terrapin.
Yeah, so this is a series of 3 different vulnerabilities, the first of which is a prefix truncation attack that allows somebody to interfere in the early steps of setting up SSH before the secure channel is actually set up, and may be able to cause downgrade attacks to disable some newer features that are in OpenSSH, like in 9.5, they added support for purposely messing with the timing of when the packets are sent so that an attacker can't watch your encrypted stream and be able to tell how fast you're typing and how long the words are that you are typing. And an older version of the protocol where, again, by interfering before you've set up the encryption, they could try to convince SSH to set up the encryption using just SHA-1 instead of SHA-2 algorithms for the secure channel.
Now, one piece of good news here is that in order for Terrapin to work, the connection that it has gotten in the middle of and is, intended to interfere with needs to be using either SHA-20 Poly 1305 or CBC with encrypt then MAC. These are both cipher modes that are added to the SSH protocol. And in one sense, that's good news. In a couple of other senses, that's bad news. First of all, because roughly 77% of everything allows the use of either one or the other of those two protocols. And in particular, Cha-Cha immediately leaped out to me. I'm not a really big protocol wonk, but Cha-Cha leaped out because that's the one that you want for little bitty boxes that don't have hardware acceleration for all of the CBC encryption modes that you're more likely to be using.
I think Cha-Cha 20 Poly 1305 is the default as of OpenSSH 8 or something. I don't remember exactly what version, but it came the default a while back, partly because it's fast enough without requiring any CPU acceleration, even on tiny CPUs, but also on bigger ones. And the other obvious reason was it doesn't have the same relationship to the US government as AES does. Most times, especially if you're doing bulk sending and the speed of the encryption actually matters to you, on almost all hardware, except for the very tiniest things, AES GCM is the best because in addition to being accelerated by AES-NI or the same things on AMD or ARM, it has an integrated MAC. So instead of, like you were saying, the CBC mode is encrypt the data and then calculate a message authentication code after, with the GCM mode, you get the encryption and the message authentication code in one pass instead of 2 passes. And so that makes it a lot faster. And in this case also means that the sequence number messing around that this attack involves can't affect the MAC separate from the encrypted data. The second 2 vulnerabilities only apply to async SSH, which is a Python SSH server that's used quite a lot, but is probably not the thing you're thinking of if you're a sysadmin who's SSHing into machines to do work. It's more of people building applications that do some kind of SSH, either a tool that's going to SSH to other servers and do stuff, or specifically if you're doing kind of like a fake SSH server that you want people to SSH into and do stuff, but it's not necessarily the kind of thing where you're going to run OpenSSH, the daemon.
So how worried should I be as someone with various machines that I SSH into that are mostly running Ubuntu? Because I saw some patches in the last day or so that related to SSH. Am I in the clear now or what?
No, you're not in the clear. You probably shouldn't be tremendously worried. These vulnerabilities are going to get patched in the OpenSSH server and client, and that last part is very important because both client and server need to be patched in order to completely mitigate these vulnerabilities. And for you or for myself, the majority of our SSH usage from one, Linux or, in Alan's case, BSD machine to another, there probably isn't going to be much of a window on this before everything is patched to the point where you don't even have to think about it, especially if you're smart enough to just apply all your freaking patches automatically every day, like all 3 of us do. However, if you ever use apps on your Android devices to shell into other things, I would be eyeballing that very carefully. I would also be eyeballing, any third-party applications you might be using under Windows, like Putty. And for that matter, at this point, I would be very curious to, look into At what point does Microsoft patch this issue in their own command line SSH client? Because it's easy to forget, but Windows has its own native SSH client and server now, completely separate from what's in WSL.
The version of SSH that you get in the command prompt in Windows outside of WSL is OpenSSH, though, isn't it?
It is, but it's not just going to automatically upgrade to something new because, OpenSSH did something new. Microsoft has to do it.
Right. I was just clarifying that it's not Microsoft's own SSH client. But yeah, they will still need to be updated.
Well, PuTTY has been updated already, so you don't need to worry about that one.
You do if you haven't downloaded and applied the update, because PuTTY doesn't just automatically update itself last time I checked.
Indeed.
Us Linux and BSD folks who are primarily using this as tools in between Linux and BSD machines, we have had, in some cases, or have a relatively small window before this is just patched out of existence as far as we're concerned, and we can rely on those facts. I don't think that you can safely have the same kind of assumption that things are going to be fixed in a reasonable time frame if you're using anybody's extra third-party app or packaging, be it Microsoft's packaging of OpenSSH into Windows, or be it PuTTY, the application developers, building that into theirs. Now, and again, Joe says, and this is good information, I didn't already know, that the PuTTY developers have already patched it. But again, PuTTY, unlike something that you've installed from repos in a Linux or a BSD distribution, is not just automatically going to fix itself. You need to be on top of that. You need to make sure, and that's the kind of thing that you're going to have to stay on top of for all of your third-party stuff that isn't just sitting in a repository where grown-ups are taking care of it for you.
But for those of us in the industry, we also know that there are lots of devices with embedded versions of SSH, whether it's drop bear or just terribly, terribly old OpenSSH, and those devices are still going to be out there forever. And worse, they're mostly on the server side.
Mm-hmm.
Well, I checked the app that I use on my Android phone, and the last time that was updated was February 2021, so cool.
Name and shame, Joe. Which one?
Juice SSH.
I had been using Termius, which I liked quite a bit, but recently uninstalled because it suddenly started demanding money from me. And I'm pretty sure I had actually already thrown money at them because I liked the app, and that's just kind of my default. If you'll take my money and I like the app, I'll give you money. And I went to shell into a server one morning, and it refused to let me and said I had to give it money first. So it's been removed, and I'm back to Termux, which works, but it doesn't have as many of the on-screen interface niceties that Termius did that I frankly do miss and would have been quite willing to give the money for if it hadn't been presented as you've been using this and it's been great, but now screw you, give us money or you can't work.
But SSH is something that you don't really think about because it's been the standard for so long, and I don't recall there being many issues like this in the past.
Well, and this one is really a protocol level thing, not a problem with necessarily just OpenSSH. It is more that during the handshake, when SSH is negotiating how to set up the secure channel, an attacker can increase the sequence number on one side by injecting an order message on the client before it starts setting up the key negotiation. And then the attacker deletes the first message from the server that gets sent back and then can get the sequence numbers out of shape and cause it to basically downgrade to less secure versions of the SSH protocol from years ago.
This is why when you see the WireGuard guy, Jason Donenfeld, arguing about versioned crypto, this is exactly why. Because when you have this crypto that, the underlying protocol, you can just swap in and out like little piece by little piece, chunk by chunk, it opens up the possibility that somebody can force you step by step down into something that's absolutely insecure. Whereas with a version crypto, where you're not piecemealing it out one little thing at a time, you're just saying, no, this is WireGuard encryption version 0 or WireGuard encryption version 1 or what have you. It's a lot harder to pull off this kind of attack because once you get to the point where you're like, well, okay, version 1 was just insecure and that's it. Well, then it gets a narrow grace period before, it gets completely deprecated, and you can't even start it that way if you want to,
Yeah, and I can see both sides of the argument as well. Internet protocols take a long time to change, but maybe we should not give nearly as much grace as we do. And OpenSSH, the project, has done a good job with this, as before anything happened, they started deprecating older key types and older encryption algorithms and saying, all right, as of this release, you're going to get a warning every time you connect to something that's so old that it's not going to be supported in the future. And that forced more and more people to bother, issuing firmware updates for their routers to make sure they're actually using a version of SSH from this decade, or at least not the decade before the last one.
Yeah, I was going to say they could still afford to move a little quicker on that. I mean, how many years were DSA keys still accepted after they really were no longer of an acceptable strength?
Mm-hmm.
Unified devices broadcasted private video to other users' accounts, writes Dan Goodin for Ars Technica.
Yet another instance, unfortunately, of Ubiquiti screwing over its camera customers.
One of whom is quoted in the story saying, "Recently, my wife received a notification from Unified Protect, which includes an image from a security camera. However, here's the twist. This camera didn't belong to us."
Which in turn, then you have to wonder who's seeing your cameras. And then you have to start thinking about, where are my cameras? What have my cameras seen?
That I didn't intend for anybody else to be able to see. Exactly. And this is really the stuff that tends to stick with people a lot more than, oh, my personal information got leaked by the 100th company so far this year is one thing, but somebody was watching the camera in my living room all day is a very different line in how much crap people are willing to put up with.
Or for that matter, the camera in my corporate boardroom, the camera in my R&D shops that, have equipment in there that I had cameras in that room in case of shenanigans, but now you're concerned, oh, okay, would my people have had any confidential documents out in, my R&D lab or in that boardroom? Are the cameras of sufficient resolution to pick those up? What are the odds that a person who I really wouldn't have wanted to see that data might have seen that data? What are the odds that they didn't, but somebody else did that might get it to them? Now you've just got this morass of unknowns from an issue that, frankly, you never should have had to begin with, because the whole idea of shipping off all of your security camera footage to some third party, that really never should have flown to begin with.
Yeah, although the explanation from Ubiquiti is even scarier. So they got asked what happened. 1,216 Ubiquiti accounts in, quote, Group 1 were improperly associated with a separate group of 1,177 Ubiquiti accounts, Group 2, on December 13th from 6:47 a.m. to 3:45 p.m. UTC. During this time, a small number of users from Group 2 received push notifications on their mobile devices from the consoles assigned to a small number of users in Group 1. Additionally, during this time, a user from Group 2 that attempted to log into his or her account may have been granted temporary remote access to a Group 1 account. Why are accounts randomly grouped into buckets of 1,000 accounts?
It's hard to say, but the other thing that I picked up on immediately was a small number. It's always, a small subset of our customers, a small group, a small number of affected whoever. Isn't it funny how that works? Anytime there's a feature, no matter how useless that feature is, it's going to transform the lives of billions. Anytime there's a security flaw, no matter how severe it was, small group of affected people, no biggie.
Yeah, and for security camera appliances, 2,500 people is not that small. Maybe it's not that big, but also this is a privacy breach on a level that is very severe, where I don't care how few people could see my stuff. It doesn't matter to me if one person could see my camera or 1,177 people. Anything higher than 0 unauthorized people looking at my camera is a problem.
But more importantly, again, what really enabled the entire issue was this idea of, we're not going to be at all concerned about shipping everything off to the cloud. Even when it comes down to, literally security camera footage, whatever. Ship it off to the cloud. We don't have to manage it. It must be secure. Oh, well, is that end-to-end encrypted? So if somebody else intercepts it, they can't do anything with it? What? I shouldn't have to answer those kind of questions. Send it to the cloud. Which, that's the thing. Again, when you aggregate a ton of valuable data in one place from a ton of individual smaller clients, customers, what have you, then you create something of great enough value to attack. Or, not even an attack, just to have a bug that now has a massive impact instead of a relatively minor one. And this could have been prevented either by A, not violently shoveling everybody into the cloud as hard as you possibly can. But even above and beyond that, even where you do need to move data to the cloud, even where you do have, big centralized collections of this data somewhere, well, then use end-to-end encryption. Ubiquiti didn't need to be able to watch that video. They just needed to be able to distribute it to the people who were supposed to be able to watch it. Those people could have keys with which to decrypt encrypted video that nobody at the one place in the cloud where everything came together would have had access to. But no, we didn't do that, despite the fact that you can buy $15 and $20 IoT-grade throwaway cameras aimed at homeowners right now that have end-to-end encryption features built in. Now, am I specifically recommending any of those or saying that I, tremendously trust that they've been done to the best possible specifications? No, but at least they gave it a shot. Why did Ubiquiti not even give it a shot? Why was end-to-end encryption not already there on security footage going into their own cloud? Again, I ask everybody to think about the word security and ask yourself, is that an adjective that I would apply to a vendor who behaves in this fashion? Should I consider them a vendor of security products? And
yeah, you're never going to be able to be 100% sure the software is not going to have a bug that lets a user in group 1 watch a camera from group 2. But if every camera is encrypted to a key that only the corresponding customer has, sure, they can see your stream. They just can't view it because it's all gibberish.
They can intercept your stream. They can't see it.
Exactly. I understand there's the biggest problem with end-to-end encryption is how do we make sure that only Jim's phone has the key to decrypt this video, or that Jim can access the video from wherever he wants to. And the key escrow for that is a little more complicated, but it's much easier to get right than just, we push everything in the cloud and just hope that people in group 1 can't accidentally get confused with people in group 2.
And let's also keep in mind, we talk about this being difficult to do or difficult to get right. It both is and it isn't. Yes, key escrow and all that good stuff is complex. However, I would like to point out that this is the year 2023 AD, and for well over a decade, you've been able to just apt install the Easy RSA package with a built-in OpenSSL server that is immediately ready to set up your own private certification chain, and you can issue your own certificates, not just like individual, but you can make your own CA, and you can set up a trust architecture based on that. You can issue individual keys to individual users. Like, all of this can be automated to the point where it's actually really not difficult. It's just push button, but the will to do that wasn't there.
Okay, this episode is sponsored by people who support us with PayPal and Patreon. Go to 2.5admins.com/support for details of how you can support us too. 2.5 Admins is part of the Late Night Linux family, which means that for $10 a month on Patreon, you get access to an RSS feed that contains all the Late Night Linux family shows without adverts like this. There's also an option to get just this show ad-free for $5 a month if you prefer. Some of the episodes are even released a day or so early for Patreon supporters. So, if you like what we do and can afford it, it would be great if you could support us at 2.5admins.com/support. Let's do some free consulting then. But first, just a quick thank you to everyone who supports us with PayPal and Patreon. We really do appreciate that. And if you want to send any questions for Jim and Alan or your feedback, you can email show@2.5admins.com. Another perk of being a patron is you get to skip the queue, which is what Mike has done. He writes, in the OpenZFS documentation for installing NixOS on a ZFS root file system, there is the following comment. Avoid ZFS send and receive when using native encryption. See a developer's comment on this issue and a spreadsheet of bugs. In short, if you care about your data, don't use native encryption. That assertion frankly surprised me given the reputation ZFS has for stability and the extent to which the encryption features seem to be used, along with my own experience with ZFS encryption and send and receive. My question comes down to this. To what extent do you think encryption code in ZFS is unmaintained? Do you think there is a danger in using encryption in concert with send and receive functionality?
I've seen a few reports of bugs, but not to the degree where it's hitting everyone. I would say it's definitely not unmaintained. My company is actively working with a client who's seeing an issue occasionally when receiving a lot of encrypted streams, but this issue is not leading to data loss or anything. It's just encountering a bug in the way the send receive is processed. It's not causing data loss or anything like that. And while it's true that the encryption feature was created by a company that's not really contributing to ZFS anymore, the feature is there and does work well for a lot of people. If you are having a problem with it, the open source project really depends on you to report the bugs and provide enough useful information for the problem to be tracked down. A bunch of people having insinuations or having report, I saw this one time, it did this, and I didn't capture the logs, doesn't really give developers much to work with.
And speaking of that, Alan, since you are actually encountering the bug in the real world, what does it look like when you encounter it?
ZFS returns an error saying no space, as if there's not enough room in the pool, even though there's lots of space.
So the replication just doesn't complete then?
Yeah, the replication doesn't complete. And our supposition at the moment is that something is showing up as the wrong number and giving an impossibly large number. And ZFS is like, I can't allocate that much space at once. But we're actively working with the person who's seeing this and getting information on it and working to solve it.
So is anything crashing? Is any data being lost? Or is it literally just a case of every once in a while ZFS receive says space when it shouldn't?
Occasionally, it will cause the pool to suspend. So the pool will be like, hey, something's gone wrong. I'm going to stop here to avoid any damage. And it requires just restarting and everything's back to normal. No data loss.
Okay, and this is all on the receive side, right? We're not seeing any issues on the send side.
Right, because sending is just serialize the data and send it out. And that mostly happens in user space. The receive side, when it's trying to interpret it, it can make a difference. I'm not sure if this is receiving it raw or actually decrypting it and saving it unencrypted in the end.
I haven't encountered this in the wild, but all of the issues that I've seen reported have been with raw send. I haven't seen any issues reported with non-raw send, put it that way.
The other very interesting point that we've found with this is that no one has ever reported this issue on FreeBSD, either TrueNAS Core or vanilla FreeBSD. Every single report of this has always been from Linux. And the send receive code is the same on both, only the memory management code is different. It's been a very interesting case, and we've been trying to narrow it down and be like, is it just not that many people using it on FreeBSD? But that doesn't seem to be the case. And I don't know how many people are actually using ZFS native encryption in the wild. I know there's a good chunk of them, and I know a lot of people are very interested in using it for backups because they want to back up to a less trusted destination and want their files not to be visible there. And that's the case that this feature was designed for.
The completely unscientific, non-data backed general impression I get is probably somewhere around like 10% of folks out there are using ZFS native encryption. That's just a guess from what I see in, monitoring various like help places that people ask for help and, talking to folks at conferences and all that kind of thing. There are a certain subset of people who are very serious about making sure that all their stuff is encrypted. And those are already very definitely a minority of most of the folks that are using computer storage in general. And then in the ZFS world, you also have to bisect that group again into the people who have heard of and are very nervous about the encryption bugs versus the ones who either haven't heard about it or just aren't that concerned.
Well, mostly, while there's a spreadsheet of every bug that's ever been filed on the OpenZFS GitHub about encryption, it's not a short list. It's 48 bugs, some of which might be duplicates. Actually, a bunch of are clearly identified as duplicates. But that's over a relatively large span of time. Like the bug numbers go back to the 8,000s and the current ones are in the 15,000s. And a lot of these date back to very old, out-of-date versions of ZFS. Like a lot of these are 0.8 and 2.0. There are not that many reports on 2.1. So if it was something that was happening frequently to a lot of people, I would expect to see a lot more reports on modern versions of ZFS.
That said, about 6 months ago, we talked about this. And I'm having very strange deja vu here because I'm pretty sure it was a very similar conversation that we had that some people are seeing it. The bug reports aren't great. It seems to be a problem, but we haven't got to the bottom of it. And here we are 6 months later and still haven't got to the bottom of it.
We haven't got any useful reports. Looking at the answer here, I've not seen a single bug report ever filed for the default version of ZFS that Ubuntu ships.
6 months is not a long time, Joe, to try to track down a really edge case encryption bug that, here's me saying it, only appears to be biting a small subset of users.
It's very hard to track anything down without useful reports, and either people are not bothering to file them, or it's not actually hitting very many people. And it's happening very occasionally and only to people that don't know how to file a bug report.
The other thing is human psychology. The bug that hurts somebody the worst is the bug that is the most likely to get reported and have the most time and energy spent on it by the very angry person who that bug hurt. By and large, people aren't spending an hour and a half to tell software developers how great their product was, but let that product lose their data. And the hour and a half, forget that, they may spend a year and a half telling that software developer exactly what they think of that software and how it performed. So we are looking here at a feature that, again, and I'm laughing every time I even think the words, let alone say them, a feature that a relatively small subset of users are actively using. And then you got to bisect that down a few more times, peel off the FreeBSD users who apparently have not hit the bug on down the line. And then a small number of those people, once you finally finish with all that, sometimes hit this bug and the bug doesn't lose them data. It's an inconvenience. So where that gets us down to, like I said, I don't think 6 months actually is very long, given what we're talking about here. We're not talking about a data loss bug. We're not talking about an easily reproducible bug. We're not talking about a bug that's biting people really hard when it hits them. We don't like it. We are working on it. And in the meantime, I suspect people are asking us because they're going to want the opinions of like, okay, well, what do I do with this information from folks like me and Alan? And now that we've talked about what the bug is and how it manifests, we can also talk about what it isn't. Given that we're not seeing a whole bunch of systems, rebooting when they get a receive with bad data in there. That means, we're probably not looking at a buffer overflow or a stack smash that's got you at significant risk of a targeted attack that will allow somebody to execute arbitrary code. That's probably not something that we're looking at. That drops the severity considerably. We're not looking at something that results in what looks like a good backup, but is not. Because the replication fails with that space at the beginning, that means you don't get new snapshots on the target, which means when you monitor the target to see, do I have fresh backups on my target? The answer is no, and to go in there and look at it. So that's not a huge concern. So basically what we're left with now is there is a bug here, and it may cause you not to get good backups of a ZFS native encrypted source that you want to replicate, particularly using raw send. As far as I know, this is really only impacting raw send. So what that leaves us with is, our takeaway advice is don't rely on native encryption and raw send as your only form of backup. If you want that to be one of your forms of backup, cool. But at least one of your regular forms of backup of your ZFS system should not involve ZFS native encryption as delivered over a raw send replication. That's the takeaway.
Yeah, and also if you are seeing any kind of bug, please report it with actual useful details and follow up with the bug report when the developers ask questions, because we'd really love to solve this bug, but we need information on where it's coming from. A previous bug with encryption that Clara worked on, one customer with a very specific workload across 100 machines would see it maybe one machine every 2 weeks. And only because they had 100 machines could they have it happen often enough that we could eventually track it down and write a patch for it. And it was, a very specific use case of running Chrome inside of Docker, like a freshly cloned Docker, just all at once. All these things had to happen in a certain way at the same time that couldn't really be reproduced outside of their production environment. And just the fact that they had 100 machines doing this, they were able to make it happen once every couple of weeks and eventually get enough data for us to track it down and solve it.
Well, Dan, who is also a patron, Skip the Queue, he writes, bit of a question about Sanoid and Syncoid. On my NAS, I have a storage pool for SMB stuff and a vault pool for backup. I have Sanoid set up to take snapshots of both pools. I also have Syncoid set up via a cron job. It seems to be working, but only one snapshot gets kept. Am I doing it wrong or something?
It gets a little confusing. The actual issue is a little different than what it sounds like when you're reading the question. And the critical thing to understanding it is seeing Daniel's troubleshooting steps. The first thing Daniel shows us is a ZFS list type snapshot of the dataset storage on the pool vault. and it has several hourly snapshots that it shows. The next thing that Daniel does is he does a ZFS list T-snapshot vault storage and pipes it through grep sync. Now, what doing that does is it gets rid of all of Sanoid snapshots, and it only shows you the ones that match the keyword sync, which in this case is going to mean Syncoid's automatic snapshots. Now, these are not taken by Sanoid, nor are they managed by Sanoid. Syncoid, by default, will immediately take a snapshot when you invoke it. It will use that snapshot as the newest snapshot in an incremental replication stream. And once it has successfully replicated, it will look on both sides for old sync snapshots and get rid of them. So immediately after a successful Syncoid replication, you should only have one Syncoid snapshot, and that's the one that it just took prior to that replication.
And if you want more snapshots, then Sanoid needs to deal with that.
Yes, there's no reason ever to want more than one Syncoid snapshot, because they literally, the only purpose of it is to make sure that you get all of the data that's present on the system by taking a snapshot immediately before you begin replication. And then the secondary purpose is, assuming you allow Syncoid to take those snapshots and you don't ever go in and manually destroy them yourself, then you'll never get out of sync between your source and your target, because they will always have a common snapshot.
Right, well, we better get out of here then. Remember, show@2.5admins.com if you want to send any questions for Jim and Alan or your feedback. You can find me at joerest.com/mastodon.
You can find me at jrs-s.net/social.
And I'm at Alan Jude on all finer social media networks.
We'll see you next week.